Hello all, welcome to my YouTube channel. Today I am going to continue from the previous session. In the previous session, the geometry of the structure has been created as well as assigning the material after defining them and defining the section and assigning the section to the geometry as well as assigning the boundary condition or support condition at the base of the structure. And here we see M30, M20 and M25 grade concrete and Fe490 as rebar material. And we see in the blue line, it means the material has to be assigned 8 or not assigned 8 to this structure. And we see the columns of 700 by 700, beams of 400 by 700, and secondary beams of 300 by 500, the shear wall. And we can easily select from the works wizard in the tree menu. Suppose if we have to select the M20 concrete, in which element they are assigned, it can be easily seen from here. And for now, let me make all the concrete for horizontal element as same. Suppose here in the secondary beams it is M25 and in the main beams it is secondary beams M20 and main beams M25. So for understanding purpose, make let me assign the secondary beam as M25 also. So first of all, I select the secondary beams and the concrete grade M25. Let me click here, let me drag and drop in the working menu. So we see all the M25 concrete are assigned to horizontal members. This is very powerful tool in Midas Learn. Select the component, drag and drop which we are going to assign. So after this, let me again go to the boundary tab. We see here the beam in release. Here in the secondary beams connecting to the main beam at the edge of the structure, the moment shall be released. And why the moment should not be released in the intermediate beam, I will make a separate video later. But for now, let me assign the beam moment release at the end or at the edge of the secondary beam. So let me select the beams. Let me select the beams, and if we select in the plan also, all the beams in this alignment can be selected, or all the floor beams can be selected in Midas Learn. So here we see the boundary type, beam in release, boundary group name is default, and we see here the uh, type of release. Pin means if we apply on pin, we can see the release in both the end. So we have to go for pin fixed, and this is applied here. So we have to move this one to this edge. So let me select fixed pin and try. Okay, this one also. Okay, this one. Oh no, this is drawing from this side. So this selection depends upon the type of modeling in which edge we started to model. So let me click this one. Okay, this one. Okay, this one. Okay, this one. Okay, this beam. Okay, and finally this beam. Okay, so these are the, here is another one is applied. If we click here, okay, so the beams assigned is, let me click pin fixed, fixed pin. Okay, so these are the beam in release assigned to the structure. So after this, let me turn into the load tab. So in the load tab, we see different types of loading. The first one is the static loading. We are going to assign in this structure or the equivalent for the equivalent static analysis. The second one is the dynamic loading. So if we see the dynamic loading, here is the option for loading the response spectrum load case and the time history load case. different options here we will discuss later. And another one is the temperature and free stress loading. We see uh, the option to apply for the temperature load as well as free stressing load, which includes the pre-tensioning and post-tensioning in the beams and the slab element. And after that, we see the moving load. Here, the moving load can be applied according to different countries' standard, British India Euro code on the beams element as well as on the plate elements. So Midas then has ability to calculate to analyze the structure, applying the moving load on the structural line element or the plate element both. So we see another one is heat of hydration. It is applied in the case of mass concreting, because in the mass concreting, suppose in the raft foundation, heat of hydration occurs, and due to the chemical reaction of cement and water, and it is applied to control the initial cracks initiated in the mass concreting, or in the case of pipe cooling system, etc. And similarly, there is another option called construction stage analysis. In the construction stage analysis, in the case of tall building or skyscraper, we do simultaneously adding the loads in the floor. It means that due to the adding of addition of dead load in the structure, there will be the chances of differential settling or the differential settlement or the axial shortening of the column. So in order to avoid such type of failure or such type of deficiency in the structure, the construction stage or construction sequence stage analysis is very important. So Midas then automatically considers the construction, have the options to analyze the construction stage analysis. And if we go for settlement or miscellaneous loading, we see the options for input the settlement analysis data in the case of foil foundation or massive foundation. And another option is the imperfection loading, which occurs due to the poor workmanship or imperfection that can be occurred or that can be happened at the time of uh, construction stage. So this is very important in the case of tall building or any other structure, and Midas has automatic uh, consideration of imperfection loading. So let me turn into the static loading case. Here in the static load case, we see the different options for creating the load case: structural load or mass, lateral loading, beam load, pressure load, and initial force or miscellaneous force. So first of all, let me create the static load case. Now let me create the dead load. Here we see the dead load, and in the description you can write anything to understand, but I don't want to write here now. So let me click live or superimposed dead load. It is also a type of dead load which includes the loading on the floors or on the masonry infill wall loading. And let me click live load. Select live load. We see the different loading options present here. So let me click live load, and for now let me click equivalent earthquake load. For equivalent static analysis, select earthquake and EQY in Y direction. So we can assign define the wind loading in both the cases also. But for now, let me set only this parameter because I am going to analyze the structure for seismic loading called equivalent static analysis or linear analysis in this case. So let me close this one. So after defining the load case, let me turn into the structural load. First of all, let me go to self-weight of the structure. In the self-weight, it includes the dead load of the structural elements, and we see the self-weight factor of +1 for Z. So let me go for -1 and let me click OK. Then we have assigned the self-load factor of vertical downward direction, and for now I don't have any nodal load. If we have any nodal load acting horizontally or vertically or any moment, we can apply from this wizard, and we don't have any specialized or specified displacement in this case, and no any nodal body force and Now let me turn into the load to masses tab. Here in the load to masses tab, this is very useful in the case of lateral analysis or lateral loading. So here the mass direction is I said to xy. I will discuss why this xy have to be selected, and the acceleration due to gravity is 1. And first of all, let me go to add the load case, dead load of 1, load factor of 1. Similarly, superimpose dead load also 1, and for the live load I like to put 0.25. This gives the seismic weight of the structure, and this seismic weight of the structure, floor-wise seismic weight, can be applied in the form of lumped mass at lateral loading. So this value gives the seismic weight, and the portion of this seismic weight, or the story shear, story force, or lateral force, some portion of it can be applied to as a form of lumped mass in both x and y direction, as we have put only x and y, not considering any planes or not considering any particular effect of the earthquake. So let me click OK. Here, if we turn into the structure type, we see the convert self weight into masses, means convert to x and y. This is the case that in this structure here, lateral earthquake loading is applied in this direction and in this direction, x and y direction. No vertical earthquake is considered in this case. So this one is not. So we have selected the x and y axis to apply for the seismic loading in lateral direction, x and y direction. Okay. So after assigning the load to mass, let me turn into the seismic loads. Here we see the different loading wizard for wind load and seismic load, as well as our pressure load. For now, let me go to the seismic load. Let me add. We see the load case we just have assigned, and we see the different seismic load codes according to the different country standard. For now, let me select IS 1893 2016. Let me select the seismic zone factor of 5 and the soft soil and importance factor. This depends upon the type of structure. For now, let me select 1.2, the damping percent of 5%. And if we go to structural parameter for fundamental time period calculation, here are the formula for different categories of the structure. So for now, let me select this one, or either we can select this one, and it depends upon the type of the structure. I have already mentioned this is the height of the structure. It automatically considers from the story height. So let me click OK. And for response reduction factor, it also depends upon the type of structure. Either it's a moment frame, or it's a shear wall building, or it's a dual frame structure, or it's a steel building. There are the different value mentioned in the code. We will see later the exact value, but for now let me select the 5. And here we are considering the x direction, so load factor for y direction is okay, is 0. And for accidental eccentricity, we can select any of these option, and for torsional amplification we can include the accidental eccentricity. So if we consider none, so no need to amplify the torsional value. And if we have any seismic load, additional load, we can add here. We can click the value in certain floor and coordinates and add here. And after that, let me click apply. But before that, if we see the seismic load profile, we see the applied load in x direction. These are the lateral force or seismic force induced due to the earthquake loading application. And this is the story shear profile we see. And if we see the base shear here, if we see the base shear is 1893.8679 kilonewton, and story moment is this one. And if we see the overturning moment, this is the profile of overturning moment, and we can copy this sheet into the report as well. in this format. This is the .svf format, Midas Learn text .svf format. And let me close this, and this one also. Let me click apply. Here, apply and OK. So we see the earthquake loading in extrusion has been applied in the form of lumped mass. So here are the three arrows indicates the three different coordinates for typical floors in the top story and just story just below the top story. So again, let me go to load, seismic load, apply the loading in y direction. Let me click y, q, y. All the parameters are similar like we have mentioned just before. In Oh, I forgot to select 2016 version here. Same period calculator, same for now. Response reduction factor of 5, and the directional factor is 1 for y direction, none, no, and we don't have any additional seismic load. And this is the similar load profile for story force, story shear, and story moment for y direction, and we will see the base shear as well and the overturning moment at the base. And for now, let me click apply. Okay, we see the seismic load has been applied in the structure. Okay, so this is the application of seismic load, and after that, let me turn into beam load. If the masonry wall loading have to be applied on the beams, we can select this tab, and this can be applied as a form of UDL or triangular load or concentrated load, trapezoidal load, etc. But I don't have any loading beam load to apply here. And you see after application of beam load, there is a pressure load. In our model, we are not modeling the slab, so the slab loading can be assigned as a pressure type load in the slab structure, slab element. If the live load of 3 kilonewton per meter square have to be applied, on the slab we have to go for defining the load type, assign the pressure load type from the pressure load. But for now, we have to apply the slab floor loading in the line element. So let me go to assign floor load type. Here, first of all, define the floor loading type. Suppose, let me name some name floor load, which includes uh, all the loads that can be applied. After defining the floor load, here we see the dead load of -3, STL of -1.2, and live load of -3 combination are making a group of floor load that have to be applied on the floor. Now we can apply this load with the tributary area on the beam. So let me go to assign floor load, assign, and let me select the story 2 below active. So here, let me go to the assign floor load. Here the load type is floor load. The distribution is one way and two way. Let me select two way here because we have the two-way distribution of the load to the beams, and tick or select the yellow polygon type unit area. And here let me define the nodes to be applied. Okay, here this is the shear wall void, here, here, and here. Okay, so we see the load has been applied, the floor load has been applied on the beams with the tributary area. We see the load, this portion of the load is applied to this beam, and this triangular portion to this beam, and so on to all of the beams. Similarly, let me go to third floor, active, select, okay, and again go to fourth floor, okay, fourth floor, and similarly all the loads has been applied can be applied like this, or simply we see here the copy the floor load option, we can translate the floor load up to the story or up to the level which we are going to apply. So this is the way to apply the floor load in the beams. Okay, on the 15th floor, let me select the 15th floor. Okay, and finally the roof. Okay, yes. So with the this way all the loads has been applied. So this concludes the application of loading as well in the structure, and after this the analysis will be done and we will process the result before the design. So till then, keep watching these videos. Don't forget to like, comment, share and subscribe my YouTube channel. Thank you.